Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 2.6, and it can be found on pages 78 and 79. We're going to be using the idea of ratios and proportions and apply it to perimeters and areas. So the first thing that I want to define, a ratio is a fraction. A proportion is two equivalent fractions, okay? So a ratio is a fraction and a proportion is two equivalent fractions. So the first thing we're going to do is perimeter. And we're given two rectangles. We're given two rectangles, and we're told the perimeter of rectangle A is 4, and the perimeter of rectangle B is 6. And we want to know what is the ratio A to B of the perimeters. And remember, ratio is a fraction. A ratio is a single fraction. Okay? So let's talk about ratios. Ratios can be written one of two ways. We can write a ratio like this, A to B, or we can write it as a fraction, A over B. And we want to know what is the ratio of the perimeters, A to B, so A to B. So my perimeter for A is 4, and my perimeter for B is 6. Now 4 and 6, that can be reduced. They can be reduced, they can each be reduced by 2. So we're thinking of this as kind of like a fraction. So my ratio is 2 to 3. And then if we set it up like a fraction, it is 4 to 6. And now we can see where the reducing comes in. It's much easier to reduce it when it looks like a fraction. So we divide by 2 over 2, and that equals 2/3. So the ratio is 2 to 3 or 2 to 3. So when we're talking about perimeters, perimeters are linear. It's the outside of a figure. And a ratio is a simple fraction. So that's how we find the ratio of perimeters. We can set it up like this, or we can set it up as a fraction. In my opinion, setting it up as a fraction is easier. So now let's talk about the ratio of areas. The ratio of areas. So we've got two triangles. Triangle A, triangle B. They are similar triangles. The area of triangle A is 6, and the area of triangle B is 10. And now when we're talking about area, we're talking about the squares inside the figure. Okay? So when we're talking about area, we're talking about the squares inside the figure, and squares are two-dimensional. They've got length and they've got height. So this question is asking us, what is the ratio A to B of the areas? What is the ratio A to B of the areas? So once again, I can set it up like this, A to B. The area of A is 6, and the area of B is 10. So we can reduce these. They can both be reduced by 2. I've got 3 to 5. But we're talking about area. And area is the squares inside. And the squares are 2-dimensional, length and height. So we need to square our ratio here. So 9 to 25. So the ratio of the areas, A to B, is 9 to 25. So 9 squares inside to 25 squares. Now, frankly, I think this is easier to see if it's written as a fraction. So the area of A is 6, and the area of B is 10. So we can reduce these fractions to simplest form. But since we're talking about area, the squares inside, and the squares are 2-dimensional, we need to square our ratio here. So it is 9/25. So this is the ratio of areas, A to B. Okay, so that's all fine and dandy and everything, but how do we apply that? How do we apply this? Well, we're going to use what we learned yesterday, the idea of proportions. So we now have rectangle A and rectangle B. The width of rectangle A is 10. The width of rectangle B is 18. The area of A is 200 yards squared, and the perimeter is 60 yards. We want to know the area of B and the perimeter of B. We want to know the area and the perimeter of B. Can we do that? Absolutely we can. We're going to use what we learned yesterday. They're similar figures. So there's the tilde that says they're similar. A is similar to B. And we're going to use the idea of proportions to figure out the area and perimeter of B. Okay. So let's start with perimeter because I think it's easier, it's linear. So perimeter, we have A over B. We have the length of A over the length of B. And that should be equal to the perimeter of A over the perimeter of B. So here again, we're looking at corresponding parts. Here's the length of A and the length of B. The length of A over the length of B, corresponding parts. And then we're talking about the perimeter of A and finding the perimeter of B. So the perimeter of A over the perimeter of B. Okay, corresponding parts. So now at this point, this is exactly what we did yesterday. We have a proportion set up, and this is exactly what we did yesterday. So 10p equals 18 times 60. 10p equals, let's see, 1080. I want to find the perimeter, so I'm going to isolate p, divide by 10. What I do to one side, I must do to the other. And the perimeter is 108 yards. So the perimeter is 108 yards. Okay? So now we're going to do the same thing for area. But remember, area is the squares inside. Area is two-dimensional, length and width. So let's talk about area. So we're going to use the idea of proportions again, A over B. We're going to use what we already know, the length of A over the length of B. So we're sticking to corresponding parts again. But now we want the area, So the area of A is 200, and we want to know the area of B. So once again, we're talking about corresponding parts. The area of A over the area of B. Okay, so now we're going to, well, since area is squared, because remember area is the squares inside, and area is two-dimensional, length and width. Since this area is already yards squared, and this is only yards, this is yards, and this is yards squared. Right now, this is like oranges is equal to apples. That's not going to work. So we need to square this. So we now have 100 yards squared and over 324 yards squared equals 200 yards squared over the area yard squared. So now we have apples and apples. We're talking about squared, the squares inside. Now I can cross multiply. 100A is equal to 64,800. I want to isolate my A, so I'm going to divide by 100. Divide by 100. Area equals 648 yards squared. So the area is equal to 648 yards squared. So this here is kind of perimeter and area in a nutshell. Perimeter is linear. It's one-dimensional. So it's exactly what we did yesterday. We've set up a proportion or equivalent fractions. We're cross-multiplying to find the missing parts. We're doing the same thing for area. We're setting up a proportion, but since we're talking about the width here, this is linear. It's one-dimensional. And area here is the squares. It's two-dimensional. We cannot compare one-dimensional things with two-dimensional things. So we need to even them out. We need to make them the same. So to do that, we're going to square our linear measurements, our linear dimensions. Once we do that, we're now comparing apples to apples, squares to squares. Then we can use the proportion, cross-multiply to find the missing measurement. But we can only do that when we've made apples to apples, when we've equalized it, when they're both squared. So that's what we're doing today.